Morning, students. If you can maintain silence, we will start the next program. Students at the back. Thank you. So, good morning, everyone. I'm Dr. Sulakshna, Associate Professor, ECE Department, Vardhaman, and IIRS Coordinator for Vardhaman Nodal Center, here to welcome you all for National Space Day celebrations. Respected dignitaries, our chief guest, Professor V. Seshagiri Rao sir, retired scientist, Satish Dhawan Space Center, ISRO, our HOD sir, Dr. P. Nageshwar Rao, and Dean R&D, Dr. J. Krishna Chaitanya, and faculty coordinators, and my dear colleagues and students. We welcome you all for National Space Day celebrations. Today, we gather to celebrate this occasion, India's National Space Day. This day marks a significant milestone in our nation's journey to the stars as we commemorate this day for the achievements and contributions of our space pioneers. From the launch of Aryabhatta in 1975 to the historic landing of Chandrayaan-3 on the lunar surface, India's space program has come a long way. Our space agency, ISRO, has demonstrated exceptional ingenuity, dedication, and perseverance in pushing the boundaries of space exploration. India's space program is not just about reaching for the stars, it's about improving the lives of citizens, enhancing our national security, and inspiring future generations. As we celebrate this day, we honor the visionaries who paved the way for our success. We recognize the tireless efforts of many scientists, engineers, who worked behind the scenes to make our space dream a reality. So let us contribute to strive for excellence, innovate, and push the frontiers of space exploration. On this occasion, I take few more minutes to tell you about Vardhaman Student Satellite Program, which was namely VSAT, which is a project that inspired many students to come together from various engineering disciplines and allowed them to share their ideas that held together to develop a payload for student satellite. This was 3 years back in our college. Developing a student satellite involves developing many subsystems, which in turn involves crucial stages and working for engineers from various engineering disciplines such as electronics, communications, electrical, computer science and IT technologies, etc. Among many steps, the first and foremost stage to run the satellite successfully in the orbit up in the space is satellite ground station. Our Vardhaman students has developed indigenous ground station to receive satellite data in the form of images and voice. As a proof of concept for the developed ground station prototype in our college labs, we even received data and images from International Space Station and submitted back to the international space agencies like NASA and Roscosmos, which is a Russian space agency, and the students won awards for this technological contributions. Also, our students participated in many international level competitions and received laurels and awards. In this regard, I would like to thank our college management and principal sir for extending their support in encouraging young minds of Vardhaman. With these few words, I like to leave now, saying only one thing to our students. Students with the knowledge who has knowledge as wings can fly high to great heights at Vardhaman. As a faculty and as a management, we always be there at the back to support such ideas coming from you. So let's choose such good projects to implement your ideas that make our college and nation proud. Thank you. Have a happy National Space Day. With this, now I like to invite Dr. P. Nageshwar sir, our HOD, to come on to the dais. Now I'll invite our chief guest, Professor Seshagir Rao sir, to come on to the dais. So now I'd like to briefly introduce our speaker today, our chief guest, Dr. V. Seshagir Rao sir, who is a former distinguished scientist and associate director, ISRO. He worked at Satish Dhawan Space Center, Sriharikota from 1976 to 2015. He has retired as distinguished scientist and successfully held various key posts at ISRO. As an associate director, deputy director, range operations, project director, multi-object tracking radar, deputy director, vehicle assembly and static test facility, and he was also a controller for chief of administration, and he's worked as chairman for standing review committee for software development, and he has accomplished many more things during his service in ISRO. He has participated in all ISRO launches for more than 39 years in various capacities. He was responsible in realization of state-of-art new mission control center. As a project director, he was responsible for design and realization of first phased array radar in India and best in Asia. He also worked as a range operations director for 7 PSLV missions, chief of data processing for 6 PSLV and 3 GSLV flights, chief of range operations for 3 PSLVs including Chandrayaan-1, and he coordinated in integrating PSLV and GSLV launch vehicles on launch pad. He was also responsible for realizing real-time systems, computer networks, and softwares for launch activities, and involved in preparing software standards for ISRO. And he has contributed his scientific knowledge to the scientific community by publishing more than 63 papers in national and international journals, conferences. He also guided many PhD students and several MTech students. He also authored a book in Telugu, Mars Orbiter Mission. Telugu title is Aruna Grahaniki Vijayamantamaina Bharatadesha Sahasa Yatra. He has won many awards like Space Gold Medal, ISRO Merit Award, ISRO Performance Excellence Award, Lifetime Achievement Award in Science and Technology, Engineering Seva Ratna Award by ECI Foundation, and many more awards in the list. With this brief introduction, I like to invite Seshagiri Rao sir to speak few words.
Good morning to all of you. Head of the department, Nageshwar Rao garu, Sulakshna, Associate Professor, and other faculty members, and my dear students. How many of you by this time on 23rd of August 2023 was eagerly waiting to see live video of Chandrayaan landing on Moon? Can you raise your hands? Fantastic. So that shows that, this particular landing was broadcast in railway stations, bus stands, hotels, schools, colleges, airports, and wherever public places you go. And in fact, the movies were stopped, and then in between the live landing was played. That was the actually participation of the Indian citizens in the Chandrayaan-3 landing. And till now, in the world, if you take the number of people who watched a particular video live on record, 50 crore people is Chandrayaan-3. And still it is a record, and then thanks for the students and the citizens' interest on this landing episode. You are able to connect? Yeah. You can switch off this. No, AC I want. Doesn't matter. Yeah. Yeah. In fact, this particular landing on Moon has made India as the first country to land in South Pole. So that is very, very significant, and many attempts by various nations could not do that, especially on South Pole. And you see the atlas made by Chandrayaan-2. It is such a detail that this is the photo picked up, the atlas of Moon made by Chandrayaan-2 orbiter. So you are aware that Chandrayaan-2 orbiter is live even today? Yes, Chandrayaan-2 orbiter is live, even though Chandrayaan-2 lander has failed to land. It has last minute crash was observed, otherwise it was a successful mission. Can you go to the next slide? Yeah. This is something I want to do you know on Earth who has actually traveled to South Pole? The Earth South Pole is 1909. The person here, you can just to draw the comparison between the South Pole of the Earth and the South Pole of the Moon, this particular slide is made. You don't worry, because the time given to me is small. There are two talks as per Professor Sulakshana. So requested for two talks, one on Chandrayaan, otherwise is a general talk, where all of you can participate and become entrepreneurs in space activity. So this, you take it as an information to you, and then probe what has happened in 1909, and then what is the difference between the environment of Earth South Pole and Moon South Pole. Next slide. Yeah, why actually everybody wants to go to South Pole of the Moon? Will anybody has looked at the details and seen the technical details in the web? Can you raise your hand? The South Pole is very important because, you know, the Moon doesn't have any atmosphere, not even carbon dioxide. Nothing. When there is absence of atmosphere, the only way you can have is, if the human is to sustain there, is the presence of water. If the presence of water is abundant, then I can take the ice water or the ice there and convert into hydrogen and oxygen, and then I can use it as a fuel for my rocket, and as well as life to sustain there. That is why in South Pole everybody thought that we will be having abundant of water in the frozen form. If you have abundant of water in the frozen form, then what will happen if there is a sunrise and sunset? You all know that one lunar day is How many days of Earth Day? 14 days is the daytime and 14 days is the night time. In all the 14 days daytime, 14 days, 14 Earth days is one daytime of lunar day. If that is the case, 14 successive days, if there is a sun shining and the temperatures in the absence of atmosphere go up to minus 140 degree, will the water sustain there? No. But South Pole is something. You have large craters and the sun angle to the South Pole is always 20 degrees in one direction. If it is 20 degrees in one direction, if there are hillocks, if there are valleys, if there are so many craters, always there is a shadow region which is actually casted by the heaps and heights. If there is a shadow region, that shadow region is even on the daytime is also permanently present. If the shadow region is permanently present, the temperature is minus 120 degrees. So that means even though sunshine is there, wherever sun shines it is plus 140 and wherever shadow is there it is minus 120. Believe that that shadow, casted shadow was present from the last so many billion years. If such is the case, whatever water molecule entrapped there is likely to be present eternally. That is the secret. If you are able to capture that much water there, then future the human habitation is possible. I am not talking about human tourists there or human landing there. I am talking about human habitation. Go to the next slide. This is what the South Pole place where India proposed to land. Next slide. Yeah, this is the Chandrayaan-1. You know that it was launched on 18th November 2008 and 14th November 2008 it has reached the orbit, and we have Kalam has suggested the moon impact probe. Just fire a small missile, get it impact on the moon while traveling both in the trajectory and impacting. You collect the details in such a way that they are useful for future mission. And in addition to that, we are able to see the hydrogen OH ions there, OH plus. So that shows that water is present in small volumes. Next one. Chandrayaan-2. Chandrayaan-2 has got two parts. It has got an orbiter and lander. So by the time the orbiter and lander together circled around the moon, and the day where the lander is supposed to separate from the mothership and then land on the moon surface, it has traveled well, the trajectory was good, and at about 2 kilometers height, the velocity that has been imparted onto the vehicle is supposed to be reduced to the 0 meter per second when it hovers around 100 meters altitude. But at 2 kilometers itself, the velocity was not reduced much. There were a few issues related to both design and as well as software, and after 2 kilometers altitude it simply crashed. But the orbiter, which is making a vigilance over the landing, and the function of the orbiter is to collect the data from the lander and send it to ground. In addition to that, it has to take the images of the moon surface and make an atlas. That is what you have seen on the first slide, a beautiful color atlas. Next one. This is the landing attempt on that day, that is September 10th, 2019, and you can see the plot there, and around 2 kilometers height, the velocity was not reduced as expected, and it simply crashed. Next one. What was done? So you have two experiences. One is Chandrayaan-1 and Chandrayaan-2. So what was done to make Chandrayaan-3 a grand success? If you broadly categorize into the domain-wise, there are 6 important things. One is on the structure. The structure of the lander, if the legs break because of the impact, you are likely to lose the lander. So you strengthen the legs in such a way, you improve the structural stiffness and the thermal. If you have a thermal management so that it will survive both shadow region and sun region. The moment lander lands on the moon surface, on top of the surface you have plus 140 degrees centigrade, and bottom you have minus 120 degrees centigrade. And it was designed to function for one lunar daytime, that is 14 days. The reason being, afterwards, in the cold region, the electronics were not, let us say, made to survive in that region. The reason being, it requires a bit of heating, and later it can be done. The first experiment point of view, they want to see that electronics function in the daytime. That is the thermal management. And the mechanics, actually, you have a motor. You have totally 5 motors in Chandrayaan-2. The central thruster, exactly that they are called the thrusters. The central thruster was removed. The other 4 thrusters were increased in capacity and as well as in point of. That means the capacity, what I mean is, it can operate from 10 Newton to 1 Newton thrusters. And the RF and baseband, you have the data transmission point of view. You have in Chandrayaan-2 a minimal data, whereas when come to Chandrayaan-3, it was 1 to 4 kilobits per second, almost 4 kilobits per second. And you have an X-band data which were transmitted to 500 kilobits, and it's omni coverage antenna, and then you are able to get board data. And the power, they have enhanced the power battery capacity from 52 ampere hour to 63 ampere hour. Then you have the capacity for the switching packages. So the moment you want to operate power in optimal way, you have a good switching mechanism. These 6 were the improvements. Next one. That's what I told you. The area selected was 4 kilometers into 2 kilometers. In Chandrayaan-2, it was larger, 30 kilometers into 10 kilometers. That was made into 4 kilometers into 2.4. The reason being, if you select 30 into 10, and my God, it is terrain point of view, it is a terror. Because when you have the craters and you have the hills in such a way that it is very difficult to pinpoint where to land. Whereas a evenly surface area, 4 kilometers by 2 kilometers, you select it, and then you can narrow down an area and land there. And the slope while landing should not exceed 20 degree slope. If more than 20 degree, it is likely to tilt. So this was the management plan for landing. And you can see the curve there. You can see in the 14 days, when the moment sun rises, it is a 0 degree elevation followed by maximum 20 degree, and it settles. So you don't get overhead sun there. You get a maximum 20 degree elevation. Next one. Now this is the Bahubali vehicle used for the launch actually. All of you know it, and there is no need to mention and keep the details available. All the details are available, and the launch day was on 14 July 2023. Next one. This was the trajectory. We have the 2 solid boosters. We have 2 solid boosters, and then followed by L110 and followed by a cryo stage. All those things will impart a velocity equivalent to 10.2 kilometers per second to the vehicle which is supposed to orbit the moon. Why I paused here is I am looking whether anybody will look for the escape velocity of the Earth. What is the escape velocity of the Earth? 11 kilometers per second. So we almost reached 10.2. But will it go to moon? No. And do you increment it to 11 kilometers? Yes, you have to increment. But the moment you want to increment to 11 kilometers, even though you call it as a Bahubali, you have no fuel there. So what do? Keep the fuel on the moon orbiter itself. That is why it is called a propulsion module. Earlier it was orbiter and lander. Now it is a propulsion module and lander. Both were together. So propulsion module is sufficiently loaded with fuel. Let us see. Next one. This was the reason anyway. We have gone through again. Next one. And these are the dimensions and where the experiments were loaded. What are the types of experiments and what is the type of the lander? These are some details. Probably sometime later, if time permits, we'll have a look at it. Otherwise, we remember that this is the type of the orbiter and the lander and the rover. It has got three parts: orbiter, lander, and rover. Okay, next one. Pragyan rover. So these are the experiments. So what are the types of experiments? Actually, if you look at it, one is you would like to see what kind of particles there. You have all aerosols on Earth. Do you have any kind of a particle there? If so, what are they? And because of the sun radiation, or do you get any solar particles? You want to measure it. If there are X-rays, you want to measure it. If the temperature, you want to measure it. And let us say you want to photograph it. And then later on, you want to, after landing, you want to see are there any quakes, moon quakes on the surface. So these are the experiments. Actually, you can go through them very well, and all the experiments were made successful. Next one. Now this is the one. What does it indicate? So it has made over the Earth, it has made 5 orbits. Why it is to be done like that? Because when it was injected, it was the first orbit. Later on, each time the propulsion thrusters was fired for certain duration, so that it comes to the second orbit, it comes to the third orbit, it comes to the fourth and fifth. You may ask actually, why 5 times you have to fire? Can you fire single attempt? Possible. But we want to calibrate. We want to calibrate. If I fire for 5 seconds, what is the velocity added? If I want to fire for 10 seconds, what is the velocity added? If you want to calibrate all the experiments, you want to calibrate the thruster, this is an advantage. Doesn't matter, I may be spending 3 or 4 days extra there. Then, after reaching 11 kilometers per second, it is no more in the Earth influence. It will be traveling towards the moon. So moon is orbiting around the Earth. The travel, when it is picked up 11 kilometers per second, it is traveling with the influence of which planet? Earth is rotating around Sun. So that means when it attains 11 kilometers per second, it is like any other planet. It is a man-made object in the heliocentric orbit. That means it is a small orbit around Sun. What is the velocity? Then moon has got 1/6 of the gravity. If somebody lands on the moon and you want to have an escape velocity, will it be 11 kilometers per second? What it will be? I said 1/6 of the gravity. You take 12 and divide by 6. How much it comes? 2 kilometers. When the object is traveling at 11 kilometers per second, will it get attracted by moon? How? It simply flies off. I said it is in the heliocentric phase. So this 11 kilometers have to be brought down to 2 kilometers per second. See what is happening? The Earth, around the Earth, the moon is orbiting. So your lunar object where supposed to land on moon is traveling, both will meet at a particular point. At the moon influence time, you have to fire thrusters in the reverse direction, decelerate it, and reduce the velocity to 2 kilometers per second. If you are not able to reduce the velocity within time, you can write off. So you reduce it and orbit around the moon, maybe roughly 100 kilometers by 40,000 kilometers, and gradually decelerate it to bring it 100 kilometers circular. Next one. What does the lander contains? The lander contains, because this time the lander was built with a number of sensors. What are those sensors? The velocimeters and inertial sensors, altimeter. The carbon altimeter is the extra one added because altitude measurement is crucial here. Then the hazard avoidance sensor. So that means what? How do you avoid hazard avoidance? How do you avoid hazards? Let us say you will be traveling on the, let us say, Hyderabad roads, and you know where the pits are, where the turnings are, and where the things. At a particular point, I always if I want to take left turn, from 5 kilometers back onwards, I used to keep on left side. Finally, I see somebody taking a U-turn. For U-turn, what that fellow will do? He used to put some obstacles. Then I am traveling extreme left. It's not possible for me to again negotiate and come back on the right side. So you have to be either in the middle of the road or do something. So same is the case here. The moment I want to land a particular surface, I have taken the image of it. That image was stored on board, and while orbiting I take images, while landing I take images, and those images are compared with my expected landing place, and thereby I avoid hazard. It is some kind of an expert system with artificial intelligence. Next one. This is what was done. So there 1, 2, 3, 4, 5. In all 5 phases it has been taken. Next one. These are the improvements. Anyway, we talked about the improvements. I said the central thrusters was removed, and the 4 thrusters around the circumference was made more robust. And the algorithm modification point of view, one particular correction was done. The moment, let us say, you want to accelerate a car, you have an accelerator. It depends on how much you press on the accelerator so that acceleration will get imparted onto the car. Do you uniformly press it? No. You may not be able to press it uniformly unless you reach maximum and keep your foot there. So what is happening when you fire anything, even your tap, you open it to the maximum, I don't think you get continuously the same speed. Same is the case here. When I want to fire a thruster for 10 seconds, all 10 seconds, each second you may have a small tolerance. The tolerance is on the incremental side, the velocity is extra. The tolerance is on the negative side, the acceleration or the velocity, final velocity is something less. That is why instead of taking a 5 seconds burn or 6 seconds burn unilaterally, I will calculate the total thrust. All 10 seconds put together, what is the total thrust given? Thereby you decide whether you are able to decelerate that much. That was the improvement done. Next one. Those improvements are summarized here. There was a special safety feature which says that don't land on slopes more than 20 degrees. Next one. This was the change of the specifications of the thruster for Chandrayaan 2 to Chandrayaan 3 and the corresponding algorithm. Next one. And this is the control room on that day. All were anxiously waiting. Next one. You see the phases. This is the last 15 minutes of terror, people say, because you don't experience earlier how the spacecraft will land here. And the first one is the rough braking, you are reducing roughly 1.68 kilometers per second to almost you are reducing it to 621 meters per second vertical velocity and 358 meters per second horizontal velocity. That takes around 690 seconds. And the second one is the altitude hold phase. That means more or less near horizontal way we want to fire and then make it tilt. So that earlier the spacecraft was in horizontal and we want to make it tilt in such a way that the legs will be facing towards the surface of the moon. That was the altitude hold phase. And then velocity direction, it is called fine braking. By the time it reaches 100 meters, the velocity will get reduced to 10 meters per second, whether horizontal velocity or the vertical velocity. The moment it is 10 meters per second, and slowly you decelerate in such a way that it lands on the moon. That's what is called soft landing. The moment you reduce the velocity to 0 meters per second, it is called soft landing. And you know, even though it is a soft landing, you have a moon's gravity. Because of the moon's gravity, you get lot of dust there. And after that only you can conduct any experiments. That dust has to settle. Next one. This is the communication. So you know that we have a deep space antenna in Bangalore. This is called 32 meter. This is called DSN 32. You have lander landed on moon. You have a rover. From the lander it gets separated and moves on the moon surface. So any data from rover will communicate to lander. Lander will send directly to ground station. Or Chandrayaan-2 orbiter is there. If that link fails, we know that Chandrayaan-2 orbiter is still working. The lander will send it to Chandrayaan-2 orbiter and that orbiter will send the communication to ground station. That means you have a redundancy from lander to ground station. The propulsion module which was transmitted, which was sent to let us say moon's orbiting, doesn't do anything except maintaining communications with ground to transmit what has on the combined module. Next one. This is on the day 00. It has landed nicely. Next one. Okay, you just press it. All of you must have seen it. Probably we'll skip this after a second, 10 seconds or so. This is the horizontal altitude hold phase, and this is the landing, and then okay, next one. Yeah, this is the one, you know, after on 24th of August, the next day, the rover has come out and the rover wheels has got Ashoka symbol and national symbol, and the symbol is seen on the floor actually. Next one. This was the landing site. As I said, like you have the latitude longitudes. These latitude longitudes will make where to land in a precise manner. Next one. These are the landed the rover track. Next one. Okay, this is how it has, this is the live one. This is how the rover has landed on moon. Okay, you can skip it. All of them must have seen already. Okay, next one. Yeah, this is the track of the rover on that day. Does anybody know that at what speed rover has traveled? Less than a meter per second. You can imagine how much time it took to travel and come back. And in fact, ISRO has done a unique experiment after landing. You have sufficient fuel. The lander has got sufficient fuel, they designed a new experiment. You lift it on the moon surface by about 2 to 3 meters, again land it back, only to know how much thruster capacity you have to use to lift from moon and again land it back. That was also done, in fact. Next one. This was the experiment conducted on the temperature profile. You see on x-axis temperature and the y-axis is depth of the moon surface. What was the depth actually? Minus 60 millimeters. Minus 60 millimeters to 20 millimeters. Positive side, minus means you have gone inside. And positive side is 2 centimeters. That means for about, this was 8 centimeters. So 8 centimeters to 2 centimeters, what was the change in temperature? Minus 10 degrees to 60 degrees. Do you find similar temperature difference on the earth? No. This shows that the earth crust is thermally insulated. Okay, next one. This is what are the materials we can find there. The finding of some of the materials which are shown here, the aluminum, calcium, ferrous, chromium, and many things. Out of that, the phosphorus one is a surprise. Normally, that elements were not found. Next one. This is the thing related to the quake monitoring on the moon surface. Next one. This is the camera. Next one. And what happened, you look at some of the missions, the Luna 25, Russians have launched a bit late. They tried to land earlier than India. They failed. What has happened? It crashed on the surface. They are unable to reduce the velocity. And the SLIM, that was Japanese thing, it was launched on 19 January 2024. It was landed upside down. And Peregrine, there was a propellant leak. It has not landed at all. And Odysseus, that has also failed. That means what? I don't think the landing on moon surface is an easy job. Next one. You know that why we are celebrating this day is Chandrayaan 3 landing on 23rd August 2023. That point was named as Shivashakti point, and earlier Chandrayaan 2 crashed. That was named as Tiranga point. Okay, next one. Next one. So many companies, there are many startups. Everybody wants to go to the moon. Why? There are so many reasons we'll discuss later. Next one. This is another one, Artemis 1, like Apollo. US wants to have an Artemis. I'll be discussing in the next presentation. The Artemis 1 is such that they want to build International Space Station. From Earth, you take a capsule, dock it to International Space Station around the moon. That is called Gateway. And then there is another capsule, you move into that capsule and get it detached, land on moon, do your work, come back and get attached to the gateway and take the capsule meant for coming to Earth and come back. That is the total idea. Maybe you will be seeing in the next decade. Next one. This is how actually the International Space Station around the moon is supposed to be. Next one. This is the Chandrayaan 3 and 4 with the Japanese collaboration. It is called Lunar Polar Exploration Mission, LUPEX, with the JAXA, Japan Aerospace Exploration Agency. And very soon this will be announced. Next one. That's all. Thank you. This is the how it has happened on 23rd August 2023. Hope all of you are familiar. It is only to recap once and tell you what are the modifications and how it was achieved, and then what are the experiments conducted and what are its results. So this is the talk on Chandrayaan 3, and a couple of 1 or 2 questions, probably we can take it. Okay, we'll quickly take the other one. Can you change it to other one? You see Vardhaman 2 is there. You close this one. So we have time up to another 20 minutes. So bear with me if I skip some slides. Slideshow. Slideshow, please. Yeah. So you will be surprised actually, the space technology nowadays, not for making a rocket, not for making a single satellite, no. Those days are the olden days. It is meant for real-time observation of the entire globe, whether you are in the geosynchronous orbit or LEO orbit, low Earth orbit, or medium Earth orbit. Is it possible, low Earth orbit, to keep a satellite and the entire globe to be monitored? No. With a single satellite, not possible, because it makes one orbit in 1.5 hours and Earth is also rotating. It's not possible. And let us see what's happening. Next one. And Government of India and the United Nations put together, whatever I told, the space research in, let us say, 2022, before and after. The 2022 before is called world space. Now it is new space. The reason being, not only the government agencies, you know how many nations are making rockets and putting satellites into orbit? Hardly half a dozen plus, maybe 8. And you know how many countries are using satellites? 100 plus. So 100 plus countries are using satellites, but launch makers are not many. Then how do you, let us say, fill the gap? The only way is making the public to participate. You allow public to make rockets and satellites. It may be a startup, it may be a consortium, or it may be students or academicians, whatever it is. So totally, if you take, go to the next one. Yeah, people can start their own space activity, either in the satellites and payloads, launch vehicles, or human habitat on the extraplanetary systems like Moon, Mars, various things. And if you want to make a startup, what are all the areas? They are all listed here. You can consult me at any time. Next one. This is the one. What are these small dots on the world map? They are the launch pads. Launch pads in the universe, either currently operational, under construction, or military, whatever it is. How many in number? More than 50, maybe half of your strength here. So many have come up. Next one. And in addition to that, space-based platforms are there to launch. I can launch a small rocket which can take 500 kg satellite from a ship platform. That's what going on. Next one. And based on that's what the space platform launch. And people are recovering, you press again. People are recovering the boosters back. That's what, the second one, the booster is being recovered, is landing back. And because of public-private partnerships, The mechanical engineering, civil engineering, and electronics and communication engineering, computer engineering, aerospace, all are starting startups. You know how many startups are there? More than 200. You see the graph there, 2023, 105 in India itself. And there are some capitalists which will provide you fund to you. Next one. These are the small launchers. Everybody wants to make a small satellite and launch it. The bigger satellite, PSLV and all those things require 1.8 tons to be filled as a satellite mass or number of satellites. Otherwise, if I have 400 kg satellite, I need a small launch vehicle, small satellite launch vehicle. ISRO has made one on 16th of August actually. These are the people, private people, more than 43 in number, who wants to make small satellite launch vehicle and operational. No, we listened that 8 of them are countries. All remaining people are private. Mostly in US, Europe and India. Next one. And single satellite launch and observation are the old way of concept. Let us say I want to observe, I want to take a photograph of the earth every 10 minutes. The entire globe. What do? I orbit hundreds of satellites. All of them simultaneously take a photograph. I combine them into a globe. That means I need hundreds of satellites. So the hundreds of satellites meant for taking an image of the globe is called Earth observation by optical camera. So Earth observation by optical camera is one area, and that constellation is meant for taking a photograph of the entire globe. That is one application. I have listed here the number of constellations that are coming worldwide are this many. You see in the x-axis. In the x-axis you have the company names. You have Planet Aerospace, you have many people, SpaceX, OneWeb, whatnot. And you know how many satellites they want to launch? Hundreds. Hundreds of them meant for, each one is meant for one application. Next one. These are the applications. Each application, how many constellations are being configured. You can see here, the y-axis is the applications and the bar chart are the number of constellations. For example, you take the longest bar that is meant for IoT. IoT purpose alone over the globe, 81 players are there with respect to constellations. You can imagine. So you can list all the applications and you can look at the players. Next one. And you know, the India is concerned by 2030 you are going to have 77 billion space economy. So it is meant for people like you to come up with ideas to make a startup in space application. Next one. These are some of the success stories. You can see here on the right side, you have Agnikul, you have Astrogate, you have Dhruva, many people. And as I said earlier, there are 100 plus. And you know, space application, there are two types. One is downstream, second one is upstream. Whatever subsystem you make that is going into fly in a rocket or satellite is called upstream applications. Subsystem goes into either a satellite or a rocket. Or the downstream, where you have a ground station, you have a link to receive the data and then process. You have servers. That is called the downstream. You have upstream or downstream. Majority of the people are on the downstream because upstream, not many are required to make actually. Next one. These are some of the examples, you know. We have in India Galaxy, which is starting a constellation for Earth observation. and you have small satellite, Agnikul and Skyroot and all. Next one. This is one, if any one of you, including colleges, if you want to fly a satellite, if you want to fly a board on experimental basis, and if you want to space qualify it, PSLV has got a poem. That is, poem is nothing but PSLV orbital platform, which is meant for doing experiments. So on this deck, ISRO is providing free ride. People can make an experiment, people can make one small satellite, keep it here and observe with your own ground station. That's it. Why I have kept specially it's for you? Because if I remember well, during COVID time, the students like you has converged, and Sulakshana and other faculty members have organized a kind of a 14-hour course where you can make a satellite of your own. And that was done in Vardhaman College by me. And that is why this slide is meant for you. You don't require to make a satellite. You make a meaningful experiment where it can be ported here. That's it. And the telemetry will be provided by the vehicle telemetry itself. And you have to book in advance. Okay, next one. And you know, we said so many satellites are being launched. Nobody is going for 1-ton satellite, 2-ton, 3-ton, 4-ton. The satellites are from Cadbury chocolate size to 100 kg. They are all called small, mini, micro, nano satellites. Can a Cadbury chocolate size satellite can fly? What antenna will have? What transmitter will it have? What data it will transmit? What payload experiment it will have? It is meant for qualifying a subsystem. Make a subsystem, fly it, qualify it, and say that you have made a space qualified subsystem which is meant for marketing. You can see here. And you know, normally a standard size like your instrumentation racks, the standard size in one of the models is called 1U satellites. 1U satellites are nothing but 10 centimeter cube, and it weighs 1 kg or 1.3 kg. And I can have like a Rubik cube, I can attach these 1U satellites into 2U, 3U, 6U, 24U, it's up to you. That means there is a scalability if you take 1U satellites. And if you want to make a 1U satellite, the total cost involved is $20,000, not more than that. There are people who provide the structure to you and components to you, not components, subsystems to you. You have to make only the payload. The payload weight you get in 1U will be 300 grams. You make a 300 grams payload, insert into the structure, fly it, receive it on your ground station. You don't require to make solar panel, structure, thermal system, computers, antenna, receiver. No. They are all available in the market. Just buy them, integrate them, put your payload, launch it, and then receive your data. That is why I am showing this particular slide to you. Next one. The startups, if you want to see the heading wise, what are all the areas the startups have been started? These are the areas. Small satellites, in-orbit services, ground stations, artificial intelligence, advanced payloads, whatnot, many things. Quantum communications. Quantum communications is likely to be the one which is required in future. Hope some of you must be starting here. And these are the areas actually. You can make a startup and make a beginning, irrespective of your, let us say, your engineering discipline. Next one. This is the one, another one, space tourism. In fact, I am working with Virgin Galactic, US, and last 2 years we had some discussions of future missions. You see here, everybody will think that if you want to fly to space, you need hours and hours of training, you get tired, and you know, If you are not able to withstand that velocity and acceleration, your health will spoil, many things. It's not required. The moment you want to fly as a space tourist, you look at the top, buy a ticket, take two days medical examination and training, and take a liner, sit on the seat provided to you, take a selfie at 100 kilometers and come back. That's it. What is that market? That market is going to be very high. It is around maybe $12 billion. And what is the ticket here, Virgin Galactic? $4.5 lakh, one ticket. And you know, it is surprising to know that yesterday when I am talking to CEO Alistair, he said 500 people are waiting to take the ticket. And if you want to orbit 1 week and all, the ticket is exemplary and cost is very high. Next one. And you know, see, you have a mobile now. How many of you take your mobile and if you are allowed to go to Himalayas and Amazon forest and again use it? Any of you can use it? No. Why? You don't have cell tower there. You don't have any ground link there where you can get an internet. I can't use. What do you do? If I want to go entire globe, I don't want to change my SIM. I keep my mobile in my pocket, and the entire globe, wherever I am, I want connectivity. How do you do it? Only way is internet from space. And Starlinks have already launched 8,000 satellites. It is going to be increased to 40,000. Right now he is offering for $99 per month. If you take that link, entire globe, including aircraft, you can take calls and you can take internet on the aircraft itself. So that is the way now. And you know, such a connection if you take, it has got a poppet-like antenna. You go to Amazon forest, if you have a outhouse there, or let us say farmhouse there, sit there, keep that popper antenna outside, and then connect the entire house with Wi-Fi. That's it. As simple as that. And there are people, Starlinks, OneWeb, and many people. Next one. This is what? See, the earlier slide is outdated now. What will happen when you are traveling from Hyderabad to Vijayawada to your mobile? First, your mobile is connected to Hyderabad tower, followed by next successive towers. Okay? That is what happening now. Your mobile is connected tower after tower. I'll keep the tower in the orbit. It's the mobile satellite tower. I will put so many satellites. Every time one satellite is visible to you. So the earlier one is better or this is better? Second one is better. Already people have come up, lot of market there, and it is called dish to mobile. So your Motorola is there, LG is there, Samsung is there. Already these many areas are connected. And space debris is one. I will show a slide to you. Space debris is the traffic management. We'll come back to you. Yeah. And you know, even Starlink's guy has switched to D2M. Okay, next one. This is another one. People want to do space mining. You have asteroids coming, you have many things coming. If I go there, pick up a kind of a soil, and let us say it has got an element which cannot be found on Earth, and that is useful either medicinally or material point of view. It is something you cannot substitute, and cost of that will be very heavy. People are doing space mining, and you can see here Japanese have sent something to the one of the asteroids and collected the samples. And a big market there also. Next one. This is one, this is one application. What is this? Anybody can guess? It is the ozone layer. It is ozone layer around Earth. This is being taken every 2 to 3. You can see the time running there. It is a real-time image casted by a ground computer by taking satellite data. Hundreds of satellites are around the globe. All of them, if they transmit, it will be like this. I can see instantly, every 1 hour, what is happening to my ozone hole. Why this? Why not we do pollution? It's possible. Next one. This is the one, the entire globe weather monitoring, every 40 minutes. There are sentinel satellites and many satellites. The entire thing is monitored. Next one. This is something new. How do you make a 3D imaging of a satellite, of an Earth? You have to do, how do you make a 3D map? Hyderabad city, 3D map. There is a 3D cameras. Sometimes you take 120 degrees apart 3 shots and stitch. It becomes a 3D. But if I have a sensor, gravity sensor, which can distinguish between ground floor, first floor, second floor and third floor, I will make a gravity measurement and make this once again a 3D map. Next one. This is the measurement of gravity through satellite. You see in the Indian Ocean, that blue color is different from all other things. People make gravity measurements. Next one. This is the pollution. You have seen the ozone. This is the pollution all around the globe. Next one. You see here, how many of you are using for charging your mobile a Wi-Fi stand? Nobody has used? Some circular stand will be there. Go and keep your mobile, it will get charged. How many? You have seen that? You have seen that. That means what? It is wireless transmission of small energy so that your mobile will get charged. So that's what being done. People wants to produce electricity in space and transmit to ground. It's possible. Next one. This is something. Right now you make it and earn money if you have investment. Make GPS unknown. How many satellites are required? So tomorrow you may be the space traveler to the moon and then you want to navigate. Next one. This is the microwave generator on moon. Next one. This is actually some people started a consortium to make disaster warnings to various countries freely. They don't charge anything. Next one. This is the one. You know, in Japanese, one company, they want to make solar panel on moon surface and make a substation and get it ready the moment humans land there to use it for their purpose. What is that size? You can see 11,000 kilometers. They want to house 248 kilometers wide, 11,000 kilometers long solar panels on moon. Can you imagine? I am only seeing if maybe Terra size solar panels on ground. So how many flights are required? I'll generate electricity and keep you waiting there. I will charge enormously. Next one. This is something actually, the heat shield. Heat shield is always a metal one. Making, you take a paper and make a small objects out of that. It is called origami in Japanese. How many of you make objects with paper? So many. So you can make a heat shield for a launch vehicle, many things. Next one. This is something, see, actually going to the moon is always a kind of a special effort. People are making a kind of a balloon, inflatable one. You go to the moon, inflate it, go inside, you can stay for 7 days and then all the essential supplies will be there. You come back, close like umbrella, and return back. See, people are making this. The persons who are actually making is the Sierra Space. Next one. This is something, you want to make, we all know that going to Mars is 10 months time. But whether anybody lonely can travel 10 months duration? That's why scientists are doing whether you can hibernate the human. Instead, why not we reach faster? What is the velocity of light? 3 lakh kilometers per second. What is the maximum speeds of the spaceships? 30 kilometers per second. What is it? 30 kilometers. Where is 30 kilometers per second? Where is 3 lakhs kilometers per second? At least if I double it to 1000 kilometers, so probably this is a kind of electromagnetic launch people are making so that I can reach higher velocities. Next one. This is something, see, madam is asking where you have space debris and all. First of all, how many satellites are there in orbit now? Already 8,000. It is going to be 40,000 and more, or 60,000. So ground stations required all around the earth. People are making ground stations as a business. All Hyderabad also somebody is making X band, C band, S band, KU band, KA band, L band at one place, or tri-band one antenna at one place, so that I can provide support to many satellites. Next one. This is what, madam, you look at it. See, 50,000 possible collisions were detected and avoided right now. Had it not been avoided, it could have been a catastrophe where the entire space could have been filled with debris by now. So that means what? You need a debris management continuously. You need a real time. There is one startup called Digantara in Bangalore. They want to track all the satellites and provide solutions. One is likely to. Normally, we don't provide immediate correction when they are nearby. No. I should be able to predict 2 days in advance, 3 days advance, post the command in satellite. So automatically it is supposed to maneuver back. Next one. You can go back. Previous one. You can see the traffic management people. That particular right side middle person is tensed. So you can see Leo, Geo, Mio. And all of us are thinking that we have only 8,000 satellites in orbit. In addition to that, we have 25,000 and odd debris. They are also rotating. So satellite, not only satellite to satellite collision, satellite to debris collision also you have to take care. Next one. This is something where people wants to colonize moon. DARPA is one agency, defense agency in America. It is funding all universities across the world, including if Vardhaman applies, they can also consider their application and scrutinize. And any new ideas are welcome. Next one. This is something, as I said, people wants to make an international space lab gateway around the moon and make people to travel to the moon, facilitate people to travel to the moon. This is the manifest. Next one. This is what, by Artemis 5 time, they can make international space station around moon, that is called gateway. Next one. This is the gateway. So in this, if you look at it, the left side last one is meant for taking people from Earth to gateway. And the other one, middle one, right side, that capsule is meant for you get docked, you walk into the other one, that will take to the moon and complete your work, get back and dock it here, and come back to the capsule and then return to Earth. This is going to be a reality. And anybody who wants to make subsystems here is also welcome in DARPA. Next one. This is how it makes final. Next one. This is actually gateway building. It's an animated one. It gets built one after the other. Okay, we'll skip this next one. Actually, people wants to make houses and platforms on moon. How do they make it? You see one here. You can skip off the way. No. You can put the slider. It's a 3D printer on moon. Makes platforms for rockets to land, people to land, and many things. Just we'll spend a minute. You cannot, you can see here, the shiny one round object is the Earth on moon. As seen from moon, the Earth will get seen like that. You make use of the local soil there. Okay, they make small objects like this and then make a platform. Skip it. This is the one. If let us say humans wants to stay on moon, type of constructions. Next one. Next one. And this is the total thing. Life support system inside. You have one chamber for plantation, one chamber for living, one chamber for experimentation. Next one. This is something being built in Dubai. It's a moon, simulated moon there. You have internal so many multi-story buildings. One of the floor is meant for moon surface. Everything will get simulated. This is a very big project, $55 billion. If some of you go there after 1 year, you can visit this in Dubai. Next one. This is something where, if an asteroid is coming and try to hit on Earth and you have to deflect it. For that, Americans have conducted an experiment. This is called DART. Next one. Anyway, wherever you are, you have to have the cyber security. Next one. This is another one, military, space command. People are coming for space command. Anyway, time is not there. We'll skip this. And total market is 384 billion. And how much is for Vardhaman? Next one. These are the areas where people can work. Next one. And so many startups are there. You have a big space economy coming up, and people have many great ideas to put into operation. Next one. Yeah, that's all. Space economy is for people, planet, and prosperity. That's what your celebration of Space Day is meaningful, provided you give at least a 5 minutes thought what to do to get these kind of systems come up for future generations. That's my message. Thank you. Come here. In your childhood, the moment a the father give you a bicycle, how many days you require to practice and make you comfortable in riding? More than few hours. So each hour is an attempt by itself. You do for 1 hour, come back, mom will give you something, and again go back and try it out. Similarly, when you want to master technology, single attempt is not sufficient. And in addition to that, every time you are getting the technology, let us say development, miniaturization of technology. See, whatever thrusters are used earlier, I can replace by ionic thruster. I can replace by many other new materials. You master it in such a way, you can make use of the latest technologies and make way for taking human beings onto the moon. Okay? You cannot take, for example, you take Artemis. They are not taking first time the human being. First they will run in Artemis 1 mission, which was already they have done. They launched a satellite around moon only for communication purpose, nothing else. So that is why in Chandrayaan 3, is the orbiter repeated? No, it was only propulsion module.
So, thank you very much, sir, for providing the taste of last 15 minutes terror of Chandrayaan 3 soft landing on lunar surface. And also your lecture provided insightful thoughts for our students, especially showing today's world required applications with advanced and sophisticated technologies. And also you have shown trend and economy of space industries to motivate our students to think in line to take up such projects, get experience in space technology, and implement their startup ideas. The lecture was not at all like academics ever, and I'm sure our students enjoyed the real taste of space. Thank you once again, sir, for providing such exciteful talks. Now, I like to thank our HOD sir, our Dean R&D J. Krishna Chaitanya sir, faculty coordinators, our principal sir, and management for providing opportunity to organize such great event for our students. Finally, I thank our students for having as a patient listener. Next, in the afternoon, we have 2 competitions, namely poster and quiz game. So whoever have registered for this event, you can come and participate. And also we will invite the spot registrations, if at all you are interested. Thank you. Sorry. There is a small felicitation for our speaker. Sir. I request HOD sir to come and do the felicitation for Professor Seshgir Rao sir.